This is the accessory switch panel that we've built. This will sit on the shelf that pulls out of the base. It's got 11S levers, Cobalt S levers. They control 13 points, and the odd one on its own is to control the level crossings that we got from Heathcote. This is a Cobalt Alpha. These are Cobalt Alpha switch packs. There's one blue and one green. Green is off and blue is on, and that will match the mimic board that's on the back of the train set. In the end here there's an alpha panel, and that will connect to the alpha panel that's on the layout. This is a DC supply for the lights on the switches for the alpha switch packs. The switches fit into these holes, and it all goes together, hopefully, like that. The curly cable connects to the alpha panel at the other end there. While I've been fitting these Cobalt motors, the screws that are supplied I've found are very difficult to get in. You've got to drill a hole, or mark it, drill a hole, put a brad hole in it to get these screws into a board as hard as this. So these screws, which have got a good point that will bite into the wood, I've found are the easiest thing. You can stick the Cobalt motor on with its pad in position, get it in the right place, and then you just pop that screw into there, and it bites and it cuts, and it's fantastic, dead easy. These are the servo motors for the Heathcote crossings. Quite fiddly to get them to work correctly, because as he says on his video, we've got to get movement that way with movement that way. So it's a bit tricky, but I've got it sorted, I hope. Now we've got an accessory decoder, which is there. And that is connected to the DCC supply. And from the DCC supply, it comes down to these controllers for the crossing gates. Each one of these operates a pair of gates, so we've got either side of the track. All connected up. It's easier to use these Wagos, dead easy to use, because the amount of cables to get into these connectors is quite difficult. These are the buttons that give you the control over the gates, the speed of opening them, how far they open backwards and forwards, which controls these. And I hope I've got them right, but we can sort that out later. We're putting crossing lights on. These are from Layouts for You, and we're going to connect it to this controller from Block Signalling. These signals from Signals for You, the cables are so fine and quite difficult to handle. And what I found is that the bared ends that were on it when it came are so tarnished, it just wouldn't take solder at all, no matter how I tried. The more heat you put on it, it just burns it away because they're so fine. So what I decided to do is to cut the ends off and to strip back some of the insulation again. Very tricky because it's such a small, thin gauge wire, but because I have experience of stripping cables with these and not cutting through them, I was able to do it. Here's all the bits of insulation. So I stripped it back, tinned it, which was dead easy then, it just tinned it easily. And on these we have to put a resistor on everything but the black. So it's a resistor on red, yellow, but not the black. And you get these resistors in the pack. Again, I've tinned the end of the resistor so that it'll take the solder. Without it being clean, without it being tinned, you're on a hide into nothing. So I suspect a lot of people who think that they can't solder, the reason they're having trouble soldering is because of the cleanliness of the metal that they're soldering to. It has to be clean, it has to be untarnished, and it has to be tinned. To get it tinned, it's got to be clean. You need flux. So, hopefully, I shall just show you how I connect one of the cables to the resistor. Already tinned, resistor already tinned, and because it's very, very fine and the solder that's on there isn't much of it because it's a very fine cable, wraps neatly round the end of the resistor. A bit of flux, clean soldering iron, a bit of solder, and just a touch, and there it is, it's soldered. Now what I've also done, or doing, is I'm putting some heat shrink over there to give it a bit of strength and substance, because the wires again are so thin. I don't like the thought of them being able to twist on the bit that I've just heated and soldered, because heat will affect the metal and make it brittle. So putting this bit of shrink on does two things. It insulates the end of the resistor and the cable, and it also makes it a lot stronger, because what we've got to do next is we've got to feed all this through the base of the railway, and doing that could dislodge the wires. So I'm hoping this is going to make it a little bit stronger than it would have been without. So that's the red, and on the back of there I'm putting a cable that that will connect to this or one of the circuit boards that we've got for the crossings. That will connect to there. So this cable will run to a multi-connector to then go somewhere else across the board, I think. And then all we do with that, again, it's nicely tinned, and hopefully a bit of solder, not clean enough, a bit of solder, there it is. And what I do then is I get another piece of shrink, and just, again, that's for insulation and a bit of strength for manhandling it. And one of the things I've discovered building this layout is that a lot of this product that you get is so small and fiddly to work with. There is no strength in it at all. Some of the stuff we've had I think is not fit for purpose, but that's another story. I think there's a market in model railways for equipments and other bits and pieces to be made properly, substantially, so it's easy to use. So basically that's it. So that will then, they'll all bunch together, and I'm going to put I've put a shrink over that, so that goes on all 4 of the cables, and I end up and I put a shrink wrap over the whole lot to bunch them together, so it's good and strong, and we're not hopefully pulling against these because they are very, very small. That's it.